Hello and welcome to our stream for UK RAS Robot Lab Live. We are Team Roboquarium from Heriot-Watt University, and we will be showcasing our telepresence system that we have been working on. Now, telepresence means basically operating a robot from a remote place and then having the information as if you were within the robot or kind of driving in the front seat of the robot. So what that helps with is that it gives a better understanding of what is going on around the robot, as well as just kind of being able to operate the robot with all the up-to-date information and ensure safe operation during mission. Now, Josh here will go into more detail regarding the demo today. So Josh, please take it away.
Hi, so today we're going to have our underwater ROV, remote operated vehicle. This is our Blue ROV in the water. So we are at the wave tank at the National Roboquarium at Heriot-Watt in Edinburgh. And under the water, we have our Blue ROV, which is our research vehicle for telepresence and underwater inspection. So today we'll be using this to show you how you can remotely operate this from anywhere in the world over the internet.
So Josh will first do a demo of what it would look like for an operator.
So here we have our operator page. And through here, we can see the camera from the robot. And we can control the robot as it flies around. So right now, I can give it a waypoint. And it will go to here. And then I can give it a different waypoint. And it will move to a different viewpoint of the structure.
Now, at that point, what you saw briefly was the autonomous pilot detecting that it was a bit too close to the structure. And it basically made the decision that the safest option at the moment wasn't to follow the waypoint that was given by the pilot, but to move away from the structure before performing the waypoint it received.
Through this interface, we also have control of the arm. We can move it forwards. And while it's forwards, we can close. And we can open the gripper. And we can stow the arm sideways, or we can stow it upright. So now we'd like to invite you to access the 360-degree view of the robot. And we'll do that. We will drop a link into the chat now. Hi, Claire.
So if you go to the link that's been provided, you'll be taken to a welcome page where you can either sign up for the operator experience, and then in a bit, we'll basically choose a name out of the hat, and you'll get to experience what Josh just demonstrated on your own device at home. Alternatively, if you would just like to be an observer, then in the welcome page, if you click on the observer button, you'll be taken to a page where you can see the 360 view, where we use the camera in the bottom left of the stream to generate something like a Google Street View type spherical mesh that you can scroll around and then hopefully feel like you are inside the robot and then seeing the structure. So Josh, would you like to put the link in a banner so that you
Yeah,
can have
we'll do exactly that.
people who just joined able to come in as well? So, and then, yeah, picture. While we're setting this up, if anyone in chat has any questions, please do just drop a comment and then we'll try and answer to the best of our abilities. So the banner has just gone up in the bottom left hand of the stream. If you'd like to join us at the link provided, and then you can either sign up for the operator experience or just view the environment in the observer page. Oh, we have Santi, who has joined and signed up for the operator experience. Good to see you here, Santi. I know exactly who you are, and I'm glad you were able to make it today. Would you like to say hi in the comments? Or are you too shy? We'll give it a couple more minutes, and then if nobody joins or nobody else signs up for the operator experience, then we can go ahead and give Santi, our special friend. Ah, there he is. Oh, he's come up with a sad face. What a shame. Too shy to say anything more. So the idea of this system, so currently obviously we have it in a safe controlled environment within the wave tank out area what, but in the future what we hope for is that we can deploy this system onto offshore inspection ROVs, because a lot of these offshore jobs are very dangerous for human beings to go and do themselves, and the use of autonomous vehicles such as the one we're using is becoming more popular. And one of the problems with that is that you do not exactly want to have an operator on site constantly, because that is a very high pressure job to be carrying out. So with remote telepresence, it enables the operator to be safe at home in a comfortable environment without having to work offshore and still carry out all the missions or inspections, repairs that they wish to do. Okay, so Mr. Username Santi, I am going to give you the ability to become the operator. So if you go back to the welcome page and click on the sign up button again, you should be taken to the operator page. So if you want to try that now, you should be able to see Santi joining. Ah, there we are. So that is Santi joining in as the operator just now. So if you can let us know in the comments if the website is working for you, that will be fantastic. And if not, then we can try and look into any potential problems that we may have. So if you want to try pressing any of the buttons for the arms or the grippers, or alternatively in the top right image, if you click on a location, it should send the robot to where you just click. All good? Okay. Perfect. So you see the image, you see, there we go. So that arm, having moved just then, is controlled by Santi. Where are you joining us from, Santi, today? Just to kind of give an idea of where or how far the system can work from. So currently we're in Edinburgh, and if you get to here where Santi is based currently, you might give a better idea of how remote this remote operation can really be. Ah, from London, I see. So within the same country, but still very far. Perfect. So I see that you're controlling the arm, but would you like to try, so in the top right virtual image, if you click on the location, then it'll basically send the robot to that location. Oh, is that something happening there? Yes, okay. Yeah, so it might take a bit of time, so just click once and then give it a moment. And then it will.
Off it goes.
Yeah, so that's it, having started it now. There we are. So the latency is an issue, especially if you want to have a safe system to work with. But we are looking into potential solutions for these. So there are several services available that offer very low latency connection between remote machines. Unfortunately, for today's demo, we weren't able to get it working in time, but we do have a proof of concept design that does work and is operational.
So one of the large advantages of having this click-to-go waypoint interface is that while the system, since there's a high latency, since you're controlling it over the internet, being able to click and then the robot to make its own way there is much more preferable over driving the robot forwards, because then you know that the robot's going to stop when it reaches its goal, rather than trying to stop when you see the object in front of you, but you've already crashed into it.
So even though the pilot or the operator is making all the decisions as to where it goes, the internal system within the robot is still carrying out all these safety checks in parallel to make sure that A, the point it's going to is safe, and B, there's no problems with the actual hardware, such as a potentially fatal leak. In such a case, we can make it go up to the surface to make sure it's easy for recovery, or return to a home station where it knows it can be repaired, serviced, or just monitored. And to kind of go into a bit more detail about what Santi is seeing in the operator page right now, let's see. So these blue dots that you see on the screen is basically what the navigation system considers to be trackable features. So it uses a pair of it uses a stereo camera, which is just a pair of cameras, monocular cameras, and using those two cameras, it detects features, matches it, knows exactly where that feature lies in relation to the camera, and then matches it onto a database. And over time, it builds this database of map points, and then that allows it that allows the robot to consistently track and localize itself within the environment, allowing autonomous navigation. Any questions? What's happening here? It's still working. Santi is still sending waypoints here and there. So Santi, we have a challenge for you. So somewhere in the structure, we have a treasure, which is, in this case, a yellow buoy. So if you would like to attempt to try and find this yellow buoy around the structure, and then if you manage to find it, then, well, We don't exactly have a prize, unfortunately, but you can pat yourself on the back knowing that you're a great operator. So you've only really explored one side of structure. So if you really want to kind of try and go on to the other side, so the blue dots is kind of like a good guidance to kind of figure out what shape the structure is, where it's not being explored, where it's potentially available to find new features. Oh, there we go, off he goes exploring. So you can cancel the waypoints you send by just giving it a new one as well. So right now it seems to be getting a bit stuck in the recovery loop. So I'll try and give you a helping hand slightly so we don't crash into anything. And there we go. So though this system is supposed to be relatively smart, we do still have these issues every now and then where it will go places or do some weird behaviors that we haven't particularly anticipated. But there's no fun if there's nothing to improve on. It's always good to have something to improve on, to continuously work on something or work towards a goal. Right, so if you want to try giving it another goal, Santi, if you're still with us. So welcome to those who just joined. You've joined us at a time where we've got one of the viewers controlling the robot remotely from London. What we're showcasing here is a telepresence system, which means basically allowing people from remote locations to control a robot very far away, and also with the information of what the current situation is with the robot and what the robot perceives in the moment. So the idea is that by giving better perception of the current scenario, the operator from the remote location can make more informed decisions to carry out whatever mission it is. The most relatable scenario where this is used for us working here is inspection of offshore wind farms. So a lot of the times they use these world-class ROVs to do inspection work on the masts of the wind turbine. Currently, sometimes they have to do it on site, like by being on a boat close by, or actually being on the wind farm itself and operating it with close remote operation. But with this system, what it will allow them to do is to operate it from a very remote location, such as, we're currently in Edinburgh with the robot in Edinburgh as well. But Santi is all the way in London, in theory, because it's just online. Someone from all around the world, including, I don't know, say Australia or Japan, would be able to connect and control the robot as well. So Santi, you haven't had much luck in finding this treasure yet. I'll give you a hint. There's one side of the structure that you haven't explored very intensively. So I would suggest going in that general direction to try and find something. Now you don't want to drift too far away from the structure because it is very close to the structure. It's not somewhere off from the structure. It's right next to the structure. If anyone in chat has any questions, it doesn't matter how simple it is or just only relatively related. It'll be great to hear some questions that we can answer. you want to switch to operator view? Oh, the other thing is, for those who just joined, if you would like to go to the website in the bottom left corner of the screen, I don't know quite where it is, it'll be down in that direction. You'll be able to join in and be an observer or sign up for an operator position. Now, I would recommend that for people who just joined. We're about to go on a break in about 2-3 minutes. I would recommend that you basically come back when it's 4:30, and we'll basically reset the whole system, and then give people another chance to sign up, and then be put into the hat to be chosen as one of the operators for the session. So Santi is quite close to the treasure, quote unquote. And if he just goes slightly above, you'll have the chance of finding treasure. And there it is. So he's successfully found the yellow buoy, which is today's treasure. Well done, Santi. Very proud of you. Very proud of you for finding it. Right. Well, thank you very much for taking part, Santa Claus, or Santi, I should say. And for now, we are going to go off on a break, but we will be back in about 5 minutes. So please stay tuned, and looking forward to seeing you all soon.
Thank you.
Hello and welcome back, and welcome to anyone who is just joining us. We are Team Roboquarium for the UK RAS Robot Lab Live. We are a team of engineers at Heriot-Watt University working on subsea robotics. So today we'll be showcasing our telepresence system. So the idea of a telepresence system is to basically allow operators of ROVs, which are remotely operated vehicles, to carry out inspection work on offshore structures such as wind turbines or oil rigs, and to do all this remotely. So currently what they have is they either have people on the wind farm or in a boat nearby controlling the ROV. But the problem with this is that you're basically doing offshore work, which can be quite hard on the personal life, as well as high pressure for the single operator. With remote telepresence, the idea is that we can still provide the information necessary to make informed decisions during the mission, as well as having a better understanding of the environment the ROV is in currently. And to be able to do all this from a remote location as well. So this means that even if the ROV is offshore doing work, the operator could be safe at home in their comfort, just operating it as they wish with relatively little latency. So in the previous session, which we had starting at 4, we had someone from London controlling our ROV, which is in Edinburgh at Heriot-Watt campus. So we hope that we'll have all of you basically joining up today as well. So in the bottom left-hand corner of the screen, you have a link. If you go to the link, you'll basically have 2 buttons. One is for the observer page. In the observer page, you'll get access to this 360 image where you can basically view the environment the robot is in from the first-person view of the robot. And on the second button on the right-hand side, we've got sign up for the operator. So in about 5 to 7 minutes, we'll basically see how many people have signed up for this, and then pick a name out of the hat, and then give them the chance to be the operator. So in the meantime, I'll hand it over to Josh, my colleague, to showcase what it looks like to be an operator.
Hi, so to start, we are here at the tank at the National Roboquarium in Edinburgh, and in the water here we have our BlueRov underwater ROV, so that's a remote operated vehicle. So here inside the tank you can see our test structure that we use for testing our inspection, and the robot sitting in the water. And I'm connected to our web interface here, where we can control the robot from anywhere in the world. Right now, I'm controlling it from right next to the tank, but if you follow the link at the bottom of the screen and in the live chat, you too can access this page to control the robot. So with this page, I can see the video from the robot. I can see the structure, the outline of the structure as the robot detects it, as well as up in the top right here, I have a grid view of the system where I can click, and it will create a waypoint goal for the robot to move to this position. So we can drive the robot around from anywhere in the world by clicking where it wants to go, kind of like a street view, like a map sort of thing. We also have control of the arm, where I can move the arm to different positions, as well as open and close the gripper. Moving it up and to the side. Now, as we move around the structure that we have inside our tank, we will build more of a map, and these are the blue points that you see appearing on the screen. Hi, Dylan.
Nice to have you here, Dylan. Just to kind of give a bit more explanation about the sign-up process. So on the website, after you click on the right-hand button that says sign up, you'll be taken to a login page. First thing you need to do is click on the create guest account. and then enter details as you wish, and then log in afterwards. Now, until we choose an operator, when you click on after you log in, it'll be taken to a waiting room where it says basically wait for your name to be called out and then try again later. But we're currently just waiting for a couple people to go through the sign-up process.
The 360 view?
Yeah, we can show them the 360 view as well. So just to kind of go through the process of what it looks like to explore. So this is what you would see as an observer from the website.
So you can scroll around the image to see in each direction, and everybody can pick a different direction.
Yeah, so you're not restricted to what someone else wants to see that is on the stream at the same time. Now, if you go to the welcome page, yeah, so on the bottom, top left, yeah. So this is what you'll see when you go to the link at the bottom of the stream. The observer button on the left side will take you to that 360 view, and then the sign up for the operator will take you through the sign up process required to have the chance to be the operator yourself from your own personal devices. So currently we don't have many sign-ups. So if you sign up now, you actually have a very good chance of being chosen as the operator. And don't stress, it's not a very hard thing to do. All you have to do is just click point. You just get to play around a bit. There's no responsibility whatsoever for the ROV or anything. There's safety systems in place to prevent any damages being caused. So feel free to sign up for the operator experience, because we definitely want to kind of showcase that this system is very easy to use and can be accessed from anywhere on any smart devices. And in the meantime, while people are signing up, if anyone has any questions regarding the system, please do ask. That's what we're here for. We're trying to kind of convey what the system is, how it can be of use to people out there, and yeah, what's fun about it.
So we've got a question from Harry.
Okay.
Does the image outside and inside require different processing techniques, Sean?
So by the outside and inside, I'm not quite sure what you mean. Do you mean the in the stream, the kind of third-person view, or do you mean the virtual image versus the real image?
Yeah, it might be the two different images.
Right. If we're talking about the two different images that's shown on screen currently, yes, it is a slightly different process. So we use a operating system called ROS, Robotic Operating System, and the images in the bottom left with the fisheye image, that is basically streamed straight through as it is, essentially, to the operator page. Whereas the two images on top, those are the virtual representation of the environment. So that is basically how the ROV perceives the world to be. That is the points you see in the top two images are gained from the navigation system we've got on board called SLAM, which stands for Simultaneous Localization and Mapping. What it does is it basically, using a stereo camera, which is just a pair of monocular cameras, it detects features, trackable features, which it identifies as unique. And then, because it's a stereo pair, it's able to detect where it is in XY and also the depth is at as well. And what that allows for is for it to basically map these points over time as it explores more and more of these features on a structure, and then build a full map that it can use for localization, which is basically just placing itself within the environment, kind of understanding where it is and where it wants to go. And also, navigate using that map as well.
So I see them inside the water. So the question might be, if you've got a camera outside, if the camera's outside the water, does it require different processing to be inside the water? Is that the question?
If that's the case, then in a sense, yes. So the images you see in the operator page is purely within the robot, but we've got a GoPro.
We've got a camera fixed in the tank so that you can see what's happening under the water as well. But these two cameras that you're seeing me showing on the screen just now, these are just for the stream. If you were out at sea exploring a wind turbine, you wouldn't have these cameras under the water. So as part of the user interface, we have the systems that you can see on the ROV.
So our question, are we using solid state LiDAR for underwater?
So the problem with using LiDAR underwater is that the laser basically gets scattered and refracted very severely, especially with haze, which is very much a case when you're working out in the ocean. So LiDAR is a very difficult sensor to use for precision mapping and basically, precision mapping is what it would be used for. And you're right, precision LiDAR is very much used for normal robotics in the outside world, but for underwater specifically, it's not quite the right fit of a sensor to be used. Instead, what we do use is the stereo camera pad that we see here. Alternatively, we also use sonar. So that's a sensor that we can only use in underwater scenarios, but it works really well for detecting objects in the same way LiDAR would.
So we've got another question from Santi. It's, what is the purpose of the QR codes?
So I can answer that. So this is used, the markers that you can see on the structure, they are used for, we use these to validate the mapping that our system can do. So we don't need markers to create the map that you see on the screen just now, the points that represent the shape of the system. But by using these markers, we can test to see if the size of the object of the scan that we do with the stereo camera matches up exactly to what you would get if you had markers at known distances across the structure.
Do you want to get the link up again? So any other questions? But these are really good questions coming through, like very satisfying to answer. So if there's any more, please go ahead. Nice thumbs up, Santi. Thank you. So in the web view, we actually see something quite interesting. So right now you see the blue points as well as a set of red points. So what's happened there is that at some point, the SLAM system that we just discussed detect or lost tracking of the structure and decided that, well, rather than being completely lost, it'll create a new map that it can localize on. So as time goes on and it starts to build a bit more of a map, eventually it'll reach a point where it can basically understand that these two maps are essentially the same and then merge the two into one and then continue operating as normal. How easily it can merge these two maps depends on the environment, or such as lighting conditions, the amount of haze, the similarity of the features. The more varied the features are, the easier it is to basically identify that these are two unique things that can be matched on together. With the QR codes everywhere, you do kind of end up with a case of, well, actually, no, that's not true. Even with all these QR codes, which seem relatively similar, the system is still able to differentiate that these are completely different features. So in scenarios where humans might be unable to perceive any difference from one view to another, our system is still very capable of making sure that it's in the right place, localized, and safely navigate and operate.
So yeah, so I think that can answer the question. If there's no LiDAR, then how is it reconstructing the scene? Is it sonar or stereo? You can answer that.
Yeah, so I mean, just to iterate through again, currently we do, the current demonstration is purely using stereo camera. So that is enough for most cases where there's clear visibility and you don't have to worry too much about particles in the water or anything like that. But in the real world applications in the offshore structures, you end up with a lot of haze and as well as a lot of kind of particles floating in the water. In those scenarios, you really do want to use sonar as well, just to kind of act as a secondary option to kind of rely on when you have no view with the stereo camera.
As a perfect example, we have done offshore work, and with the camera system, we, on a very bad cloudy water day, we can see the structure from without we have a special dehazing system on our camera, on the stereo camera part. And without that, we can only see when we're within 3 to 5 meters of the structure. Past that, if we turn on our active dehazing system, then we can see between 10 and 15 meters away from the structure. But if you're any further away from the structure than that, you won't be able to see it, and you have to use, it's like looking into a fog, and you use the sonar acoustics in order to see up to 120 meters in front of you. Dylan asks, what would happen if the water was moving? Would the robot be able to stay in a fixed position? So using the thrusters on the robot combined with the SLAM, the simultaneous localization and mapping, so the position tracking that we get through the stereo cameras and some of the other acoustic sensors that we have on board, we're able to detect where the robot is and how it's moving. And we can use this data to hold it in place and give it more power against the current to make sure that the robot does not get blown away by the current under the water. Now, the robot that we have in the tank today, our Blue Rov, it's quite a small vehicle. It works well inshore and near shore. But for when we're offshore, out at sea, we use our larger vehicle behind Matthew. Matthew, if you want to point. We have a larger Falcon ROV, which is capable of 3 knots. So that allows for you to work in moderate current out at sea.
Now, the thing of note is even the one we see back there is considered to be a small ROV. We're working with very kind of test development hardware, but in the real life, we end up seeing massive ROVs, which can be the size of a room. So it's an arduous process to kind of try and operate one in human, by yourself fully, which is kind of part of the idea that by automation or implementing automation into these systems, it kind of relieves a lot of the pressure that is placed on the operator operating such arduous and heavy machinery.
So yeah, the other question was, and they said, well, there's a mapping technique between the memory of the object and the environment as the robot moves around the object. So that's saying that using the map that we've got, we can merge it with the camera in the bottom left, and you can create a 3D model, and we can send that off to site engineers. So people that have got experience, means you don't have to send in divers. We can just send in the ROV. It will create a map, then it'll be able to merge the camera image that you can see in the bottom left to create like a 3D model of the structure.
Yeah, exactly. And also, with the 3D model ends up being very accurate to roughly 5 to 10 centimeter accuracy, or even better.
I'd say it's even better than that. Yeah. It's very good accuracy.
Yeah. So you don't have to worry about it being kind of more or less accurate than if you were to take a human diver. And in fact, because it is an ROV, you can actually go deeper than a human diver can as well. So we've actually worked with a couple of industry partners doing this work exactly for a wind farm. And they were very satisfied with what they received with the 3D reconstruction. So it has been field tested and has been proven to be very valuable.
So the map, the blue map that you're seeing just now, that will retain the image for as long as we run the system. If we restart it, then this map will go. but we can export the data from this map along with the images that the robot records in order to build a full 3D model of the system.
Oh, we have a sign up. Max Millard, thank you for joining. Since you are actually the only one signing up for the operator, I've just given you clearance to go to the operator page. So if you go back to the welcome page and then click on the right-hand side button again, you'll be taken to the operator page that's shown in the stream. There we go. That's him connected right now. So if you'd like to just have a play about, click on the buttons for controlling the arms or the gripper, and then just to remind everyone, if you click on the image in the top right somewhere, it'll basically send it to the clicked point. So if you'd like to try that, oh, there we go. Perfect. So both the arm movement that was just shown and the new waypoint that is being sent has been chosen by Max, who has joined us in stream.
So Harry asks, how will you be communicating for wireless control mode in the water? So under the water at the moment, you can't really see from the views that we have. Oh, well, from this view, you can see that we actually have a cable tether for the system at the moment, but we are able to communicate as well via acoustics, so we can chirp through the water, similar to like dial-up internet, and we have a speaker and microphone acoustic modem on top of the robot and one near the shore, and these are able to communicate at a very, very slow speed, but enough to tell the robot commands like move to this position, or for the robot to tell us I am at this position.
So while Max is controlling the ROV, would you mind dropping a comment in the chat just to kind of figure out where you're operating from? That'd be fantastic.
So we've got another question about the sensors and what they're used for underwater virtualization, SLAM and IMU.
So for underwater visual, so we're using just a general, what's the cameras?
So for the cameras, we are using machine vision cameras that we've mounted into underwater housing on our own autonomous underwater inspection payload. And this is used for the stereo imaging aspect. And whenever the structure is in sight, we use the stereo image to decide where we are. And when we're away from it, the robot is fitted out with other sensors. We have a depth sensor, that's a barometer. It measures the pressure, the weight of the water on top of it. And from that is able to calculate how far under the water it is. We have an IMU, an inertial measurement unit, which is a gyroscope and a compass and an accelerometer. This allows the robot to know which way is down and how it's turning in the world. And for movement, because you cannot use things like GPS under the water, we use a DVL, it's a Doppler velocity log. It's able to track the robot moving over the surface. So as the robot moves over the seabed, we can use acoustic sensors, the DVL, to tell how high off the seabed and how fast the robot is moving on the seabed.
So Max is operating from Ireland.
Oh, there we go. Another UK viewer. Fantastic. So that is someone from Ireland. Oh yeah, sorry. I should be very careful what I say there. A close neighbor, shall we say. But yeah, so again, a great example of how this system can be operated remotely from a fairly large distance without any issues.
The beauty is that it doesn't really matter where you are in the world, it will still have the same latency.
Yes, exactly. And also it should be that because it's just a web-based page, it'll be able to be used in any smart device that you might potentially have, like smart tablets, laptops, desktop computers, Even smartwatches, I think, if they can access browsers, you should be able to actually control it as well. If anyone is brave enough to try, yeah.
Brave enough to do it with us.
Oh, so Max, right there, you can see him pointing at the treasure of the event today, which is a buoy. Gone slightly below it, but congratulations on finding our treasure for the day.
You've done a wonderful job of mapping the structure out for us.
Yes, it's been. So I'm not sure if you can fully see it in the stream, but you can kind of tell that it's got a very good representation of the square structure. So that's the other thing. So despite, well, it's a good kind of way of showcasing that the SLAM system is very accurate when it comes to kind of mapping a structure and creating this model. Although what we see in the stream is what's considered to be a sparse point cloud, which is just a sparse representation of the actual information it retains. Under the hood, it has a much better understanding of what the structure exactly looks like. And these points can, as Matthew described earlier, can be associated with the camera images of the time and create a full photogrammetry of the model.
So what kind of control are we using? Our question, what kind of control are we using?
So for controlling the robot under the water, we use a PID controller. That's what holds the position of the robot under the water to stop it from shaking about and to make sure that it can stay in the same place and move between waypoints. And for planning between waypoints?
Planning between waypoints is actually quite straightforward. So we're running, it does, so, sorry, I'll start again. The point cloud you see is basically turned into a voxel grid that can be used for collision avoidance. So by collision avoidance, I mean, it basically just draws a line between the point it's at currently and the point it wants to go. And then it checks if there are any of these voxels within the path. And if there are voxels in the path, then what it basically does is, as you can see in the stream right now, it basically plans a path around it. So rather than going straight to the point that was clicked, it basically drew that square path. To make sure that it's basically following that path constantly, we also apply a bit of interpolation in between. Because without the interpolation, what you end up with is a very loose goal. What I mean by that is basically when you give it a goal that is completely off in the way, with a PID controller, it's not very, it doesn't try and stick to a line. It will try and get there by any means necessary. So it can do a massive arc around, as long as the, and in those cases, as long as the goal is reached, it doesn't care what path it takes. And what the interpolation allows you to do is make sure that it reaches all the points in between, and it doesn't try and do some stupid path that might actually cause damage to the ROV.
So our question, how would we stop the robot from getting caught in seaweed or other obstacles? Well, you can see in the arm, you can see that it's a gripper. It can open and close, so we can actually change the head on the gripper. So if it gets caught in seaweed or like a rope or like a fishing net, it can actually cut through the seaweed and rope, and it'll be able to get itself free. And as Sean described earlier, using the map, it can determine where obstacles are. So as Sean said, if we tell it to go from point A to B, it will check that when within point A and point B that there aren't any obstacles. So if you tell it to go to point A and point B and it will see an obstacle in between, it will go around the obstacle, and then even going around the obstacle, it will then check again that there isn't any obstacles in the way. So it will scan to find the alternate path.
Also, with the bigger class, work class ROVs, the thrusters actually end up being quite powerful to the point where it'll just cut through the seaweed without having to worry about it. With the ROV we're using currently, it is kind of small enough to the point where it becomes an issue, but with the bigger ones, it literally just shreds through the seaweed.
And one of the benefits, as we were talking about the acoustic communication, that allows you to remove the tether. So right now we have the cable tether going across the tank to the robot. And that is where the data communication is, because you can't use wireless underwater, like normal wireless, but you can use acoustic sound to communicate, like a dolphin or a whale. Using that and removing the tether would allow you to go around the structure in a spiral, spiraling around the structure without having to worry about the cable getting caught.
Nice.
Custom motors. Are we using custom motors, or are you using a normal PDC and making it waterproof?
So, as opposed to using custom motors or brushless DC motors, so the motors that we're using currently are three-phase AC motors, and because of this, they're brushless AC motors, and by using that, they are, by waterproofing the coils and having them in resin, you're able to have this whole system run in the water. So you've got the coils covered in resin as the stator, and the rotor of the motor, which spins round, that can be outside of it, open to the seawater, but that doesn't cause a problem as there's no electrics in the water at that point.
Okay, so we're going to reset the system to kind of be in the initial state again. Apologies for anyone who signed up in the last 10 minutes, but if anyone wants to have a go at being the operator, thank you again, Max, my love, for taking part. You'll have a chance again. So unfortunately, because our system kind of flushes out the list of users every 30 minutes just for security reasons, if you did sign up before, you will have to sign up again for the chance to be the operator. But please do go through to the website, which is down in the bottom left corner of the screen right now. And we hope to see you become the operator.
Bye. And we're back.
Hello, and welcome back to the Robot Lab live stream for Team Roboquarium. We are Team Roboquarium from Heriot-Watt University under the National Roboquarium. I'm sorry. Today we are here to demonstrate our telepresence system. So what telepresence is for is to basically enable people to operate and control ROV, that's a remotely operated vehicle, from a faraway distance, somewhere remote. The main demand for this comes from the fact that all these vehicles are used in offshore scenarios a lot of the time. So this could be offshore wind farms, oil rigs, just any structure that is in a hard to get location. Now, the problem with the current technology is that it requires the operator to be on site. So that has a heavy impact on their personal life, as well as the work being quite intensive because they're having to work on a boat or on a rig. That's not what we want people to do. We want people to be able to basically operate these vehicles from a safe location where they feel comfortable and doesn't impact their personal life as much. With the telepresence system, the aim is to basically provide as much information, as much useful information as possible. So that will be things like the current environment the robot is in and the situation, a good understanding of the surrounding environment, and also what the robot state is at the time. So Josh will kind of go through and talk through the demo we will be providing today.
Hi. So, in our tank, we're here at the tank at the National Roboquarium at Heriot-Watt University in Edinburgh. And under the water in our tank, we have our ROV. So this is our remote operated vehicle. This is our test bed for all of the work that we do here for 3D mapping and modeling underwater, as well as remote telepresence, which is what we're demoing today. So I am connected to our web interface, which you can also connect to if you follow the link on screen and in the live chat of the video. So here we can see the map that the robot is constructing of the structure. We can see an image of the structure live from the camera of the robot. And up in the top right-hand corner, we have a top-down view of where the robot is. And we can click on this image, and the robot will move to a new position so that we can continue to gather more data on the structure and to create a better map of the system while we search for our treasure.
So today, the idea is to give you guys, the viewers, a chance to operate the vehicle. If you go to the website in the bottom left corner of the screen, you'll have the option to be an observer, where as an observer, you basically just get to scroll around the 360 image and see things from the first-person view of the ROV. Alternatively, if you click on the right button, you'll be signed up for the operate experience. So for anyone being carried over from the previous session, I'm afraid you're going to have to sign up again. This is just mainly for security purposes. We're flushing the list of users every 30 minutes. But if you would like to sign up again, we'll basically wait about 5 to 10 minutes. And then after that time, we'll pick a name from the hat and then give them access to the operator page that is being shown in the stream right now. So please go ahead, visit the website, click on the right-hand button to sign up by create guest account. And yeah, in 5 minutes, we'll choose someone. And hopefully they'll have an experience of trying to find the treasure that is located on the structure. So by treasure, we do just mean a yellow buoy. It's nothing too exciting, but it's something that is relatively noticeable and different from the structure. And the idea is that you would have to go all the way around the structure trying to find this one object. And then once you do, we'll give you a massive round of applause as a prize.
Anytime if there's any questions, you can stick them in the chat.
Yes. And also feel free to go through to the website and then click on the left option, which is the observer experience. But to kind of explain what you're seeing on screen a bit more, the blue points you see are basically what it considers to be trackable features. So the navigation system we have on board basically sees where it currently is by tracking what it sees. Each individual blue point is a unique feature that is detected using a stereo camera. So that's just two cameras next to each other, monocular cameras next to each other. And because it's a stereo pair, what you can do is when it detects a feature, not only does it match between the two different cameras, it can gauge how far it is as well. So over time, you build this map of points, and then using this map is able to localize itself within the environment. And this allows the autonomous system to carry out autonomous navigation, frontier exploration, or taking an input from an operator and then navigating to the goal position safely with collision avoidance.
Claire's saying it's really cool to see through the camera. See, one thing we can also do, because it's a 360 video, we can we've got projects where we can use VR goggles, and you can look around it as if you're actually in the robot. Yeah, so that's quite a cool experience as well.
The system is relatively platform agnostic as well. So what I mean by that is that it can be put onto other robots, such as the Boston Dynamics Spot robot, which we have a couple of.
And even the larger RV that you can see behind there right now, it would work the same way, the same systems.
Exactly. So we seem to have the viewers being quite shy and not signing up for the operator experience. But please do, even if you have already had a go at it, like absolutely. I mean, now is your chance to kind of sign up and go again if you wish. It should work regardless of wherever you come from and whatever device you're viewing it on. So please feel free to go to the website at the bottom left of the corner of the stream and enter your details, and then have a chance to become the operator. To give a bit more context about what we use this system for, we mainly our main partners are people who do offshore wind turbine inspection. So the idea is to basically build a 3D map of the structure using these points, basically provide a fully photogrammetric 3D model at the end. And what they can use that model for is kind of basically detecting any problems with the surface of the wind turbine that they might need to address, or send some repair vehicle to patch up any damages caused. What you see on the screen, the blue points, this is a sparse representation of the robot's understanding of the structure. Under the hood, there's actually a denser cloud that can be used to match with the stereo pair image to create a full color accurate 3D model of a structure. So yeah, checking the list of users again. We do have one sign up, that's fantastic. We'll give it a couple more minutes and then see if anyone else would like to sign up. It's really not a heavy responsibility to become the operator. It is very straightforward. It's good fun. All you have to do is just click on the image, send it a waypoint. If it deems it to be an unsafe place to go, it will basically detect that and then not accept the waypoint. So you don't have to worry anything about accidentally breaking the rule off or anything like that. It's absolutely responsibility and stress-free, fun experience. And yeah, just a bit of an adventure. And any questions you may have regarding the system or what we work on or what the end goal of the project is all very welcome. Okay, so we've got quite a few sign-ups. So I'm gonna do a random number generator to try and figure out who gets the chance to do it. And we have Andy as the chosen operator. So I'm gonna give you access to the operator page in a second. So the change has been made. So Andy, if you go back to the welcome page and then go through to the sign up button again, it should take you straight to the operator page. So if you'd like to try that now, that'll be fantastic. And then you can have a go at driving the vehicle.
Also, if you tell us in the chat where you're from,
that'll be fantastic.
Quite cool.
Yeah, just to kind of gauge how far away you're operating this vehicle from.
But the good thing about this system is, regardless of where you are in the world, you control it at the same latency, you control the exact same from us sort of standing 5 feet from the tank.
Mm-hmm. So again, Andy, if you're still with us, if you'd like to go back to the welcome page at the bottom, there we go, that's Andy connected right now. So just to kind of explain again, so you got the 3 images for describing the current situation of the robot. The top right image in particular, if you click anywhere on the image, it will try and send a waypoint. Now there it basically deemed that it was too close to the structure, so it's just doing a bit of a recovery maneuver. But if you send another one, it should try and go to that waypoint. Alternatively, you can control the arm positions and gripper states in the bottom right corner of the screen. So yeah, just have a play about and then see what you can do.
See what you can find.
See what you can find. Yes, somewhere on the structure there's a yellow buoy that is the treasure of the day. So it'll be exciting to see if you can find it. I'm not sure if Andy's having some issues. So we did get a waypoint, just navigating to. So it'd be very nice to hear where Andy is connecting from today.
Andy, if you can let us know in the YouTube comments how you're getting on.
Yeah, if you have any problems, please do let us know and we'll try and fix it for you right away.
You may need an account to see them.
Yeah, okay. Oh, to the YouTube comments, I see. But if you click anywhere on top right image on the operator page, so just a simple click will send a waypoint to the system. So the point you just clicked then just there was basically either too close to the structure or inside the structure. So you're going to have to click somewhere slightly further away from the blue cluster of points that you see.
And this is describing the obstacle avoidance.
There we go. So that's the first waypoint Andy has managed to send there, which is perfect. So it works. Glad to hear it. So if you want to just kind of click around the structure and try and make the robot explore and increase the map size that is currently building, that would be fantastic. You can also play around with the buttons in the bottom right for controlling the arm, which you'll be able to see in moving in the bottom left image. And if you're using it on a smart device like a tablet or a phone, it should be the same idea. Just a simple tap on the image in the top right will allow it to send a waypoint to the robot directly. I don't know if Andy is... Oh, no, there we go. There's another point. Okay. Unfortunately, again... Oh, no. That point worked. Okay, good. So it is working. No panic.
So if you explore around the structure and see if you can find our treasure, big yellow balloon.
So you seem to have explored a good amount of this side of the structure. If you want to kind of slowly click around the structure towards the other side, it will eventually get to that point. just make sure that you're not clicking too close to the cluster of blue points, because otherwise the obstacle avoidance system will basically deem that waypoint to be too unsafe to go to, which it just did. So you're going to have to click somewhere a bit further away from the blue cluster. Yep, perfect. Exactly like so. And you can also override the previous waypoint by just clicking a new one as well, if you wish to do so. So you don't necessarily have to wait for the waypoint to be completed fully. It would also be quite good to hear where you're connecting from, Andy, if possible, just to kind of get a better idea of how far away and also the place you're operating a vehicle in Edinburgh from. One of our lighting systems just running out of battery.
And for any users that aren't currently operating, if you go to the page, you'll be able to view the camera from the robot as if you were the robot itself. We've got a 360 scroll around. So if you go to the link that's in the chat, or you can see popping up on the banner.
There we go. So we see Andy kind of exploring around the structure a bit more now.
What's the worst underwater crash we've ever had?
What's the worst underwater crash we ever had? Well, we actually had quite a disastrous situation quite recently, where which was very close to this event actually, and kind of made us quite unsure of whether we were going to be able to fix it in time. But basically, what happened is that all the computational hardware and the electronics are stored in these sealed bottles on the ROV. Now, you can imagine that water and electronics don't really work well together. And at one point, we had a massive leak that we didn't detect immediately. So we had this exact ROV in the water for about 40 minutes to 45 minutes, not realizing that it was slowly filling up with water.
Started to behave kind of strange.
Yeah, and we weren't quite sure at the time, but at the end, to kind of illustrate with this water bottle, it was about this full of water by the time we finally got it out. That kind of wrecked quite a few systems. And it was quite a hassle to try and get working again for today, but we're here.
But we're here.
Yeah.
It's working.
But other than that, I suppose there's that one time when we were offshore in Blythe, where we basically kind of got the ROV tangled around the wind turbine with the tether. And it was quite a challenge for Josh, who was operating it at the time, to untangle itself in pretty high tide, was it, that you were doing it in?
Mid-tide.
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 Still relatively.
Quite high current.
Yes.
Yeah.
That was quite a challenge.
Yeah, that was a scary experience. But yeah, that was, we solved the problem.
Right, well, thank you very much, Andy, for taking part. Seems like, I'm not sure if you're still, no, you've disconnected. Okay. Thank you very much for taking part in the Operate Experience, Andy. Very happy to have you here with us.
I've got another question from, how did you develop motion profile algorithm for the arm and underwater? Was it different compared to outside the water?
Oh, that's a very good question.
So the arm running under the water is pretty identical to it running outside of the water. So we have a 5 degree of freedom arm some people would call it 4 degrees of freedom and a gripper. So that means that there are 4 motors along the arm and then 1 motor in the hand for grabbing things. By what we have for today are preset positions where we set what those numbers are to be in order to point the arm in different directions. That's the best setup for the live stream that we're doing today. But for what we have for a virtual reality setup is we can have the gripper position be exactly the same as the hand position. So the position and distance of the pilot's hand relative to their face is the same as the gripper on the robot relative to the camera. So that allows someone to reach out. And we had someone, we were in the sea collecting seaweed samples near Edinburgh. And this was being piloted by someone from down in England near London. Was piloting the system as a partnership with us, collecting seaweed samples.
Andy, you're very welcome. If you want to let us know where you were operating from, you can give us an idea of where our viewers are from.
So far we've had people piloting the system from London, people piloting the system from Ireland.
No one from a different continent.
Anyone has any friends in Australia, please drop them the link, have them join the YouTube chat. We would absolutely love for someone from Australia.
Shall we get the link back up as
well? From someone from Australia to join the system and pilot it all the way from the other side of the world.
So the link is back up in the live stream for anyone who had missed it. I believe that's another question.
I'm struggling to sleep right now.
That's true. That's
a good
true.
Point.
Yeah, it's way past midnight right now, isn't it? Yeah. Didn't think about that.
Anyone in Australia that works night shift?
Or any Australian insomniacs that go in chat? That'd be great. We actually had an interesting working environment quite recently where one of our colleagues was in Australia for about 3 months. And then basically whenever he was working, it would be us just starting work. And then whenever we wanted to have that last minute panic communication, it would be bright and early or pretty much right in the middle of the night for him. So yeah, not the first time we worked with someone from the other side of the world, is it? See. Okay, so let's keep going. So yeah, for anyone who just joined, welcome, first of all. If you go to the website in the bottom left hand of the stream, you'll be taken to a welcome page. One of the 2 buttons on the right side will allow you to get signed up for the Operate experience. So you'll have to kind of go through, choose a username, enter password after clicking on the Create Guest Account. And once you've done that, you'll be listed on the list of users wanting to take part in the Operate experience, and we'll choose one of you to become the lucky operator to go and find the treasure on the structure. So,
of course, Jonathan, I completely agree with you.
For anyone wondering, Jonathan in chat is the one that was working from Australia, so he's had to put up with messages from us at around 4 a.m., 3 a.m.
What time would that be in Australia?
So yes, no, he's back in the UK, thankfully. So Jonathan, would you like to have a go at being the operator, wherever you may be? If you do, please do just go up and sign up, and then I'll give you the clearance level required to access the operator page. Let's see.
I think we'll skip our mid-break and just continue
we'll
on,
continue on, yeah.
until, yeah.
Yeah, definitely. Oh, there we go. I like the username you chose there, Jonathan. I'm going to give you the clearance level required in a second. There we go. So that's you given the clearance to access the operator page. So if you go back to the welcome page again, and then click on the same button you clicked on to sign up, there we go. So that's Jonathan connected now. Kind of explains through how you control it. The top right image is the one you want to be clicking on to send waypoints. And then for the arm controls, you've got the bottom right buttons that you can just click on and play around with to put the arm in different positions and different gripper positions. So there we go. That's the first waypoint from Jonathan.
Oh, Jonathan, our master ROV pilot.
So Jonathan, where are you connecting from today, if you don't mind us asking? Not Australia. Right?
Australia, by any chance?
Just waiting for the answer. Edinburgh, but Australia VPN. Stress testing the system.
That would be good. That would be good.
All
the way from North Berwick. Man, that is miles away from Edinburgh.
It is literally miles away from Edinburgh.
Yeah. Great to hear it. Oh wow, you've managed to send it quite a big waypoint there. Very nice.
Watch him go.
Yeah. So you see the way the path kind of curves. So that's the collision avoidance system. So even though it was just a simple click that Jonathan chose as a goal, the collision avoidance system is able to intelligently figure out that you cannot just go through in a straight line and chooses a path that goes around the structure, ensuring that the ROV is safe and sound without any collisions. So Jonathan, the challenge for you today is to find the treasure on the structure. So to reiterate, that's a yellow buoy somewhere on the structure or just by the structure. So if you'd like to try and find it, that'll be grand. You can also just overwrite the previous waypoint by just sending another one. So you don't have to wait for the journey to complete before you send another.
Show the 360 view.
Yeah.
So as well, if you can visit the web page on screen and in the live chat, you'll also be able to access our observer page.
So this one doesn't require any sign up whatsoever. You'll just be able to go straight to it, and then you can kind of just scroll around the 360 image as if you're in Google Maps. Or slightly cooler because you're actually in the first-person view of a robot.
So this is the live view from Jonathan operating it?
Yes. And then the view isn't dictated by what Josh is doing on screen. When you're opening it on your own device, you'll be able to choose the perspective you want to see yourself. So it's all unique to each device that is connected. So Jonathan seems to be having a slightly hard time finding this treasure that we've prepared for you. Would have expected better from someone who's had many experience working on this type of vehicle. Isn't that right,
No
Jonathan?
experience finding treasure as of yet.
That's true. That's true. We were approached at one point to use our technology to find treasure somewhere at the offshore of, where was it again?
I'm not sure.
Okay, we never got into the details, but we've had a couple of contacts regarding treasure hunting, which was not expected, but a pleasant surprise nonetheless. Oh, it's getting close. He is getting close.
I thought she knew you treasure enough.
Oh, what a sweet comment from Jonathan. Jonathan is getting very close, and you might even be able to see it in the 360 image. The treasure should be coming into view. Oh, you're trying to reach for. Oh, you're pointing at it. He's pointing at it. He's pointing at it. It's right there. Well done, Jonathan. Woo! Proud of you. Seeing us all proud. Very well played. Wow, you even managed to park yourself right up next to the buoy as well. Very nicely done.
It's almost as if you've done this before.
Yeah, it's almost as if he's worked on the system before. Very natural at it, let's say.
There it is, hiding behind the structure.
Yeah, you can kind of see the lights, the headlights.
Way over here.
In the top left, yeah. Unfortunately, it's quite difficult to see inside the water due to the reflections from the ceiling windows. Unfortunately, there's not much we can do. But yeah, no, Jonathan, thank you very much for taking part in the experience. Glad to have you all the way from North Berwick taking part. Very far away land. And if there are any new viewers, we still probably have time for one more operator. Oh, we do have a question.
Yes.
Yeah, let's see what the question is.
George?
So Harry asks, I mentioned in an earlier session that the rotor was rotating externally and the stator was inside connected to the robot. Does that mean that water is present between the stator and the rotor? Yes, there is water present between the stator and the rotor, but the stator is held within, is potted within an epoxy coating. So the stator with its coils on it for the brushless AC motor that we use for thrusters, that is protected from the water with a cable coming out of it. And then you have an outrunner similar to a brushless drone motor, which is connected to the propeller to cause the thrust and to have the thruster. The thrusters that we actually use are the T200 thrusters from Blue Robotics, if you're looking for more information on them. Thank you, Jonathan. It was a pleasure to have you control the system.
Yeah, thank you indeed. It's great to have someone trying out the system.
For those who are still in the stream, that's Harry. Would you like a shot of controlling the system? If you can follow the link in the description or on screen, you're more than welcome to operate the system.
You're very welcome, Harry. We do have Claire signed up as well.
Claire?
So we can get Claire a go. So Claire, you've just been provided the clearance level to access the operator page. So if you go back to the welcome page and then click on the sign up for the operator experience again, you'll be taken straight to the operator page where you can test out the system. There we go. So that's Claire connected now.
There you go.
So again, to explain, the top right panel is basically where you want to be clicking to send waypoints. And you can literally click anywhere. And if it's too close to the structure, then the pilot status message will indicate that it was an invalid goal.
Here we go.
And then try again. Oh, there we go. Yeah. First goal from Claire. Very nice. So if you would like to send a couple of waypoints kind of around the blue cluster of points to try and make it explore and build this map of points, that would be fantastic. Oh, there we go. There should be another one coming soon. Okay, so the one you just gave out there, it seems like the system decided it was a bit too close to the cluster of blue points. So click slightly further away from the blue points, and it should be able to send it as a waypoint. Possibly this one. That last one might be good enough. Interesting. I wonder why it's not working. So Claire, whereabouts are you clicking? Are you clicking? I mean, if you can try clicking on the directly left or directly right. Well, oh, yeah, no, there we go. Okay, that one worked.
So that's us away to the side now. On the hunt for our treasure.
Oh, it has gone into recovery mode. So it basically detected that it got a bit too close to the obstacle, or the structure, I should say. So you'll have to try sending the waypoint again. Well, it should be able to go there. There we go. And off it goes.
There we go. There we go. We're off.
You can continue exploring. I mean, I think Claire knows exactly where the treasure of the day is, but you can still have fun exploring the structure. Have a wee look around. And in the meantime, while Claire is operating the vehicle, if anyone has any questions, I see that we've had quite a few new visitors. Please do ask away. Welcome, or welcome back in the case of that you were away for a bit and just came back. But we are demonstrating our telepresence system, which is basically allowing operators to operate the vehicle from a completely different location from where the robot is actually situated. So currently we've got the robot in Edinburgh, but so far we've had people from London, Ireland, and North Berwick operating the vehicle. So, and they've all said that they've had relatively low latency. So it is a fun and functional experience as well, mainly, which allows, in the real world scenario, it will allow these operators to operate on offshore missions without actually having to take themselves or their personal lives or base their personal lives on an offshore lifestyle.
So Claire says she has no idea where the treasure is.
Oh, does she not? Okay, I see.
Oh.
So it will be a great challenge to find the treasure again, wouldn't it, Claire?
And Claire is also in London.
Oh, okay. So we've had two London connectors today, or operators, I should say.
So Harry asks, are we using buoyancy for up and down motion? So for up and down motion of the vehicle, we use the thrusters. We have 4 thrusters that point vertically, and they allow for us to move up and down, as well as to pitch and roll the robot. So that allows us to look up, down, and also to roll from side to side. We keep the robot neutral in the water, neutrally buoyant, so that means that it doesn't float or sink. And we use weights to hold it at just weights and floats to hold it at just the right amount so that it doesn't move up or down in the water, and then we can use propellers to move up and down. So it says tilt rotors. No, so it's not tilt rotors. It's we have 8 thrusters in total. We have 4 that point forwards and sideways, and 4 that point up.
And would it be neutrally buoyant as long as there isn't much current happening? It's actually quite easy for the rod to just move in any direction it wishes. So it actually takes a lot less effort than something. So even though the control is very similar to an aerial drone, the amount of effort the motors have to exert to basically move or sustain its current position is far less than it would be for an aerial drone. Because obviously, as long as it's neutrally buoyant, you don't have to worry about having to stay up or staying in the position.
So Claire's asking what the QR code are for.
So the markers that you see on the structure, we use these to validate our measurements. So we can take measurements of the structure using the camera. And we've used this offshore to take measurements of wind turbines and meteorological masts and other structures that are present out in the sea. But when we're testing within the tank, we want to make sure that everything that we've developed is as accurate as possible. So we have these markers throughout the structure that we know the distance between. So when we create our map of the structure without reading data from the markers and just building a model using only the cameras, we can then compare that to a model made using the markers, knowing where every marker is. And we can use that to work out how accurate our 3D model is. And so far, it's been passing all the tests, and it is very accurate.
And the photogrammetric model that we've managed to build from these maps that we have been building have been proven to be of very good quality to the point where even our industrial partners have commented they would like to continue working with us to kind of keep on generating these models for their wind farms, because it's a great way to, so a full 3D model with real data is a great way to assess what kind of stage the certain weathering damages might be, or the amount of biogrowth there is on the structure, which might need to be cleaned off. Things like that. What's that?
Can I get a clue? Go around the whole structure.
Yeah.
You've been seeing me.
It's somewhere you've not looked so far.
So you do want to kind of keep going along the structure, but on the side that you haven't explored. So far you've kind of explored 3 sides. There is 1 side left that you haven't quite explored yet. So that will be our clue for where to find the treasure.
So there's another question: how are we performing sensor fusion from navigation sensors?
And as you say, yes, it is. So we are using extended Kalman filter to fuse the odometry data. So that's the positional data produced by the stereo camera with the Doppler velocity log, which is a DVL. What the Doppler velocity log does, for those who might have just joined, it basically uses 4 beams of sonar?
4 acoustic beams. And it uses this to track the velocity of the vehicle over the seabed. It can be compared to an in-air equivalent of this would be an optical flow sensor. So it's very similar to, say, a computer mouse, but for underwater. So you can use the changes in position and the changes in speed with an optical flow sensor. In air on drones, and underwater we use a DVL for the same purposes.
Well, you're inching closer
Much, much warmer.
towards the treasure, which is, remember, a yellow buoy that we're looking for. And we might actually see it coming into view right now. And there we are. Claire, congratulations. You found the treasure of today. Unfortunately, we don't have much of a reward for you other than a round of applause, but very well done. And you can kind of see in the stream as well that she's managed to create a fairly good model representing the structure at the same time. Now, in the model, you might see the red and blue points. The reason there's two colors is because at one point, it basically lost tracking of the structure. And rather than just complaining that it's lost and it can't do anything, it basically decided to create a new map to start tracking with. Over time, when these two maps start to overlap in the points that they have mapped, at some point, the system will be able to identify that they're the same map, just in different locations, and then merge the two. So at the end of the day, you'll only have one map that can be used for photogrammetry rather than having to do it on two separate maps. But yes, very well done. But thank you so much for taking part in the experience. Now, we've only got about 2 to 3 minutes before we're going to have to close for the day. So any last minute questions you might have about what we work on, the system we showcased today, or just in general about robotics, then please do feel free to ask, and we'll try to answer them to the best of our knowledge. Any questions? Any questions? Just for the last 2-3 minutes, just punch through all the questions before we have to close.
Testers.
Unfortunately, we don't have enough time for another operator to have an experience, but we will definitely try and answer any questions that people might have.
You're very welcome, Claire.
Oh, Harry's got a question.
Just a minute.
If there is a manipulator, it's fixed to the ground, it cannot move the ground, but when the arm in the water robot moves, will it cause the robot to move backwards? Yes.
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 So the arm will, the weight of the arm, the mass of the arm in the water will cause the robot to shake. For example, if I point the robot's arm forward, you will see the robot shake slightly, but because of the PID controller and the position controller that we use for the vehicle, and the fact that we have 4 thrusters at the top, we can add more force to the front of the robot to help lift that arm as it's reaching further out.
And it'll be the same when it's actually doing manipulation work, where it's grabbing or moving things. We'll basically use the thrusters to try and compensate or do the counter movement that is caused by the arm movement. And that is a very big control problem that needs to be solved.
Are you compensating the movement?
So yeah, I actually kind of ended up answering that question, but it is basically just using the thrusters. So just using all the thrusters, basically calculating what the movement is, or the resultant movement of the manipulated movement, and then doing the inverse of that using the thrusters.
So the robot is always trying to hold itself in the same place at all times. And if the movement of the arm causes it to move from its station where it's keeping, the robot will add more force to get it back to this position. And it reacts very quickly and very stably, which means that the arm can be moving forwards and backwards and side to side, while the robot still holds itself within the right position.
Right, I think that is time for now. So unless there are any other further questions, which I think we're okay with. So everyone who came through to take part or to have a look at our work, thank you very much. We very much appreciated all the questions and also had fun watching you all play around with the system and then test how much it can do, I suppose. Yeah.
Yeah.
So thank you again very much. taking part, and we hope to see you again sometime soon.
Thank you.
Cheers.
Goodbye.
Bye.